Welcome to the channel Smart Farm Insight. Potatoes are one of the most important staple crops on the planet. From Asia to Europe, from America to Africa, this humble tuber feeds billions of people every single day. Globally, more than 380 million tons of potatoes are produced each year, making it the fourth most important food crop after corn, wheat, and rice. But how does a potato go from a rough, dusty tuber buried in the soil to crispy French fries, golden chips, fluffy mash, and hundreds of other products loved around the world? Today we'll follow that entire journey, from field preparation and planting to modern harvesting, processing, and global consumption. The journey starts long before any potato is planted. Farmers begin by preparing the land and selecting planting material known as seed potatoes. These are not seeds in the usual sense, but small whole potatoes, or cut pieces of larger potatoes that contain at least one eye, the bud that will sprout into a new plant. Only high-quality seed potatoes are used. They must be free from pathogens, have uniform size, and come from certified sources. Planting usually takes place in early spring, when soil temperatures reach around 7 degrees 10 degrees Celsius, about 45 degrees or 50 degrees. At this point, the soil is plowed and loosened to create a fluffy structure, well drained to avoid waterlogging and root rot. Slightly acidic and rich in nutrients, farmers form raised beds or ridged rows. Once the field is prepared, automated planters place each seed potato at the correct depth, usually 5-10 centimeters below the soil surface, and at a set distance within each row. Proper spacing ensures that each plant has enough room to develop a strong root system and a cluster of tubers. After planting, the soil is gently compacted to maintain good contact between the seed piece and the surrounding soil, helping it absorb moisture and begin sprouting. In just a couple of weeks, green shoots emerge from the ground. From this point, the plants need consistent moisture, balanced nutrients, protection from weeds and pests. Modern farms often use drip or sprinkler irrigation systems to deliver water directly where it's needed, reducing waste and limiting disease pressure. Pest and disease management is just as important. Potatoes are vulnerable to insects like aphids and beetles, and diseases like late blight. With careful management, the plants develop lush green canopies above ground, while tubers form and swell invisibly below the surface. After several weeks of growth, potato plants begin to flower. The blossoms can be white, pink, purple, or blue, depending on the variety. While the flowers are visually striking, the real focus is below ground. From the underground stems called stolons, the plant begins forming tubers. The foliage starts to yellow and die back as the plant diverts its energy into finishing the tubers. When the tops are fully mature and dry, it's almost time for harvest. In the past, potatoes were harvested almost entirely by hand, a back-breaking task. Today, modern machinery has transformed this step. On large farms, potato harvesters, massive machines pulled by tractors or self-propelled, dig into the soil, lift the ridge, and gently separate the tubers from the dirt and plant material. Inside the harvester, a digging blade or share loosens the soil beneath the row. Conveyor belts lift the soil, and tuber shaker systems and webs allow soil and small stones to fall away. Rollers and cleaning units remove remaining clods and vines. High-end harvesters are equipped with sensors, cameras, and sorting systems that can detect and remove damaged or undersized potatoes right in the field. This speeds up later processing and improves overall quality. Despite the power of these machines, they're designed to handle tubers gently, minimizing bruising and skin damage. A well-tuned harvester can cover dozens of acres per day, dramatically reducing labor needs and helping farmers harvest farm within the optimal window. Once collected, the potatoes are transferred into bulk trailers or trucks, then transported either to storage facilities or directly to processing plants, depending on the final use. For fresh market or processing use throughout the year, potatoes are stored in specialized warehouses. These facilities control temperature. Proper storage can keep potatoes marketable for many months without significant loss of quality. Before processing, potatoes are moved from storage and loaded onto conveyor systems at the factory. At the processing facility, the potatoes begin a more industrial journey. First, they are washed thoroughly using high-pressure water sprays and rotating drum washers to remove soil, sand, and any remnants of the field. Next comes peeling. For products like chips and fries, the skins are removed using abrasive peelers with rotating rollers, steam peelers that loosen the skin, which is then washed away. These technologies reduce waste. While achieving consistent, clean surfaces. Any remaining peel fragments or defects are detected by optical sorting machines and removed. After peeling, the potatoes are cut depending on the intended product. Thin, uniform slices for potato chips. Long, even strips for French fries. Diced pieces for soups, frozen mixes, or ready meals. For French fries, the cut strips are blanched briefly in hot water or steam. This step removes excess surface sugars and deactivates enzymes, helping maintain color and texture. The fries are then dried with warm air to remove surface moisture. After that, they are partially fried in hot oil to set the outer layer. Finally, the fries are rapidly frozen in industrial freezers to lock in quality and extend shelf life. They are then packed in large bags or boxes for distribution to fast food chains, supermarkets, and food service buyers. For potato chips, thin slices are rinsed to remove starch. They enter continuous fryers where they are cooked in oil at around 175 degrees. After frying, excess oil is removed, and the chips are seasoned with salt or flavorings, such as barbecue, sour cream and onion, or cheese. The chips then cool and are packed into nitrogen-filled bags to keep them crisp and prevent oxidation. In both cases, strict quality control checks color, texture, oil content, moisture level, and flavor. The next time you open a bag of chips, dip a fry into ketchup or enjoy a creamy serving of mashed potatoes. You'll know the long path that brought that simple, familiar food to your plate. It's a story of hard work, innovation, and the quiet power of one of humanity's most important crops. Onions, though small, are at the very heart of California agriculture. With more than 33,000 acres devoted to cultivation, the state produces close to 1 million tons each year, solidifying its position as one of America's largest onion suppliers. The Central Valley's fertile soil, long days of sunshine, and mild climate make it the perfect location for onion farming. Yet the journey of each bulb begins long before harvest, with careful soil preparation and precise planting. Farmers typically start planting between February and March. California's extended growing season offers more flexibility than other regions, allowing staggered planting and steady supply. Before sowing, fields are plowed to 6 or 8 inches deep to loosen soil and remove stones or weeds. Organic matter such as compost is often added, creating fertile conditions. Soil pH is adjusted to remain between 6.0 and 7.0, a range optimal for onion root growth. Drainage is also crucial since onions are highly vulnerable to root rot. To prevent waterlogging, farmers shape raised beds or level fields. Modern drip irrigation systems are usually installed before planting. These deliver half to 1 gallon of water per hour directly to roots, conserving water and avoiding disease. Planting can be done in 2 ways: direct seeding or transplanting. Direct seeding is most common. Farmers sow seeds a 1/4 inch deep, spacing them 2 to 4 inches apart in rows about a foot apart. Precision seeders sow 10 to 15 acres per day, guaranteeing uniform spacing and depth. Uniformity is critical because it ensures consistent bulb size at harvest. Some farmers prefer greenhouse seedlings, which are transplanted into the field once strong enough. Spaced 4 to 6 inches apart and anchored an inch deep, seedlings resist wind damage better. Specialized machines plant thousands per hour, covering up to 10 acres daily. This method accelerates growth and gives farmers more control over early conditions. Within a week to 10 days, seeds germinate. At this fragile stage, moisture must be managed carefully. Automated irrigation maintains a steady dampness without flooding. By the end of planting, fields appear in neat, parallel rows, stretching across the valley. Thousands of future bulbs developing quietly beneath the soil. This marks only the beginning. About 3 to 4 months after planting, onions reach the flowering stage. Tall stalks emerge, topped with spherical clusters of white blossoms. While beautiful, they signal that the plant is shifting energy to seed production. For bulb farmers, flowering indicates that harvest is near. Leaves begin to yellow and wilt, a sign that bulbs have matured beneath the soil. Farmers check depth and firmness, ensuring outer skins are forming well. Harvest methods depend on scale. On specialty farms or for delicate varieties like sweet onions, manual harvesting is common. Workers pull bulbs by hand in the cool morning hours, minimizing wilting. A skilled worker can harvest 1 to 2 acres daily, yielding 10,000 to 20,000 pounds. Manual harvesting is slower but ensures careful handling and reduces bulb damage. On large farms, mechanical harvesters dominate. Equipped with blades or rotating shafts, These machines pull bulbs from the ground, shake off soil with vibrating systems, and move them along conveyors for sorting. A single machine can cover 10-15 acres per day, yielding $200,000, 600,000 pounds. California's large-scale farms rely heavily on these machines to meet enormous demand. By the end of harvest, each acre yields between 20,000 and 40,000 pounds. Across 33,000 acres, California's output is staggering, with millions of pounds ready for the next stage, processing and packaging. Harvest does not mark the end of the onion's journey. To reach markets in perfect condition, onions must be processed, sorted, packaged, and shipped with precision. After curing, onions are collected into bins and delivered to large storage and packing facilities. At the factory gate, the trucks are weighed and unloaded. The onions tumble gently onto long conveyor belts that carry them into the cleaning and grading area. Initial inspections remove soil and debris. Conveyor belts carry bulbs to advanced optical sorters, which use infrared light and cameras to detect size, shape, and even hidden defects. Next, the onions pass through optical sorting machines equipped with cameras and sensors. Each bulb is scanned for size, color, and shape. Damaged bulbs are diverted for animal feed or compost. The rest are graded by size and weight. Smaller onions for retail, larger ones for food service or processing. Manual inspectors complement the machines, ensuring accuracy. Packaging is automated yet carefully monitored. Onions are placed into netted bags, cartons, or boxes. Many onions undergo additional processing for convenience. Frozen onions are popular in households and the food industry. Processing lines peel bulbs with pneumatic systems, then slice or dice them into standard sizes. Specialty onions, especially sweet varieties, require gentler handling and smaller cartons to minimize damage. Storage is another crucial step. Frozen onions are packaged airtight and distributed worldwide. Under these conditions, onions can remain market-ready for several months. Exports play a major role. California supplies not only the U.S., but also growing markets in Asia, Mexico, and Canada. Each shipment must meet strict international standards with certificates and quality reports. The journey from seed to shelf demonstrates the blend of tradition and technology in California agriculture. Farmers manage soil and water with age-old wisdom, while machines and modern logistics ensure efficiency and global reach. Onions are more than a staple crop. They represent resilience, innovation, and connection. From California's fields to kitchens around the world, every bulb carries the story of dedication, science, and hard work.